The curve C has equation y equals 12 root x minus x to the power of 3 over 2 minus 10, where x is greater than 0. Part A. Use calculus to find the coordinates of the turning point on C. Turning point makes me think that the gradient is equal to 0. So we are going to differentiate our function, make it equal to 0, and then solve that equation to work out the x coordinates when the gradient is equal to 0. So let's do that. Now first, in order for me to differentiate that, I want to rewrite that square root as being x to the power of 1/2. Now I can differentiate this easily. So we're going to multiply by the power, so we're going to multiply by the 1/2. So 12 times 1/2 is 6. And then we're going to take 1 away from the power. So 1/2 take away 1 is minus 1/2. Then the next term, again we're going to multiply by the power. So we'll have 3 over 2 minus times the minus x, which will be 3 over 2x. And then we'll take 1 away from the power. So 3 over 2 take away 1 is 1/2. Finally, the minus 10 on the ends there, when I differentiate that, that will just be 0. So that's it, we've differentiated. I now want to make my gradient function equal to 0 to work out the turning point. So, this is the equation that we want to solve. Let me just get rid of all of that other information. This is the equation we want to solve. Now, first thing I'm going to do here is, I don't particularly like that 2 being there. I don't like these fractions. So let's multiply everything by 2 at the beginning. That'll make this a bit simpler for me. So the 6 times the 2 is 12. And the 0 times 2 is still 0. So that's made it a little bit simpler for me. I could also divide by 3 here. I think that might be a nice thing to do. So let's divide by 3 here, and the 12 divided by 3 there will be a 4. Right, the next thing I'm going to do in solving this equation is I don't like this minus 1/2 power here. So I'm going to rewrite that as 4 over x to the power of 1/2. Because I know that minus power, all that minus power does is move the x to the power of 1/2 to the denominator. So it makes this 4 become a 4 over x to the power of 1/2. Now, the good thing then is I can hopefully see quite clearly what I'm going to do here to solve this equation. I'm going to multiply each term here by x to the power of 1/2. That's going to get that off the denominator. But obviously I have to do that to both sides. So we're going to multiply all the way through by x to the power of 1/2. So the first term is just the 4 now. The second term, x to the power of 1/2 times x to the power of 1/2 is just x, because we add the powers. So we get x to the power of 1/2 plus 1/2, which is 1. And the 0 times anything is 0. And therefore we have just found that x is 4 when we have a turning point. We now just need to work out the y coordinate of the turning point, which we can do by substituting the x into the original equation. So y equals 12 times root 4 minus 4 to the power of 3 over 2 minus 10. So 12 times 2 minus 8 minus 10, which is 6. So that's the coordinate of my turning point. Part B. Find d2y by dx squared. So this is telling me to differentiate for the second time. So let's just, I shouldn't have read this out, but when I differentiated for the first time, literally a couple of seconds ago, when I differentiated all of this, I got 6x to the power of minus a half minus 3 over 2x to the power of 1/2. That's what I got literally about 30 seconds ago. So we're going to differentiate that for the second time. So let's do it. Let's take that 1/2. We're going to multiply by a half. So minus a half even. 6 times minus 1/2 is minus 3. We'll take 1 away from that power. So minus 1/2 take away 1 is minus 3 over 2. Second term, we're going to multiply by 1/2. So the 3 over 2 times a half is 3 over 4. Take 1 away from the power, and we get minus 1/2. And that is my second derivative. So that's part B done. And then part C, state the nature of the turning point. Well, nature just means, is it a maximum or is it a minimum? Well, if it's a maximum, I know that the second derivative will be negative because it's about to start decreasing if it's a maximum. Whereas if it's a minimum, the second derivative would be positive because it's about to start going up if it's a minimum. So let's see, at our stationary point when x equals 4, is our second derivative positive or negative? So let's have a look. When x equals 4, our second derivative would be equal to minus 3 times 4 to the power minus 3 over 2 minus 3 over 4, times 4 to the power of minus a half. Just substituting our x equals 4 into here and here. So we get the 4 to the power of a half is 2, cubed is 8, to the power of minus 1 is 1 over 8. 4 to the power of a half is 2, to the power of minus 1 is 1 over 2. So we get minus 3 over 8, minus 3 over 8, which is minus 6 over 8, or minus 3/4, which, most importantly, is negative. Therefore, a maximum, because the second derivative is negative.